I'm John Olson. Welcome to the Comprehension channel, Dr. Spankenstein Speaks. This video is called Neutronic's Valence Space Calculations on August 9th, 2023. And here we go. In the Sun, a very stable and often studied star, gamma radiation, as it is called, refers to splitting the neutrons off helium and hydrogen gas. In that split of a neutron, two photons of equal electronic and magnetic charge are emitted, and one negative charged electron and one positive charged electron we call a positron. This means that light diminishes its strength over distance by the square of the axial length of distance traveled. But the electric charge, having two opposite components, does not do that. In this paper, you will see for the first time ever presented to any audience the breakdown of how the outer planets may well have a current driven by the voltage of the sun's activity, which is an AC and or DC stable connection that keeps them in their orbit with the strength of the sun's mass. Over the known history of modern math, the three dimensions we call space have been given an awkward treatment as a fixed coordinate system or matrix. The matrix completely neglects the well-known dynamics of rotation of the matrix in favor of reduced complexity as it applies to location, but it is more awkward if used for matching known data into a more chemical and atomic or planet orbital type of a structure. The better construct would be to assign the first dimension to a half line, the origin of which is a point. Then the second is the full line, which has been called the first in our current system. Having said that, the third such pair can exist at right angles so that, like the normal 3D concept in space, the next dimension is a repetition of the first and its properties. However, the third dimension should incorporate the possible rotation in, again, only one direction. It is in this spatial discussion that finally I can address the discrepancy between the cosine of 50.83 degrees that it shows as 0.631623456 on calculators and universal G, which is more the cosine of 50.8303 degrees, to give the value I used in my past 8 copywritten video productions, 0.63161877. 0.33. The square of 0.398948 versus 0.398942 gives what seems to be an error to other mathematicians and scientists of about 0.000006 and the cosine of 50.83034629 in degrees. However, looking again as I have, the square root of 1 divided by the quantity 2 pi equals 0.3989228004. Therefore, my universal G is a statistical comparison. It is 0.63161877033. The error there is only 0.000000001. To bring that into a model that has definite properties, we would only need to state the properties of a generated movement and that we have made this distinction from the conjecture and elevated that conjecture to a hypothesis. When evidence is accumulated that is useful, the model can be said to be a theory. What I have copywritten is basically the idea that universal G is a value close to the cosine of 50.83 degrees in degree format, but my G value is really 0.000346292 degrees over size, or like 50.830346 degrees if you take the inverse radial cosine of the difference. Cosine minus 1 0.000344629 equals 1.57045. Basically 1.505 is half of pi. The world is using the still used antique 1777 to 1779 math for gravitation. The word Wintle also first appeared in 1780. 0.00000000667 times the mass of the sun times the mass of the second body, our planet. And that quantity is divided by the radius, which is referring to the distance of half the orbit, or the distance from the center of the sun to the planet. And that would be 10 to the 30th kilograms times m2 of Urus. I'm going to call it Urus, the name of the planet Uranus, 8.681 times 10 to the 25th. That equals 1.72265 times 10 to the 56th, for an example. Then take that times m1 of the sun times m2 equals 1.989 times Newton's G's factor, and you get 1.1524 times 10 to the 46th. So that's Urus. The force, it refers to really what's on this radius from the center of the sun to the planet. So divide that radius of 2.946 times 10 to the 9th squared, and you get 1.327 times 10 to the 27th kilogram. However, this is 15 times greater than Urus's mass. So I've been having problems with this for many, many videos now, and I've come up with my way of doing it, which is a simplified version of what I said in earlier videos. So I'll do this way. This is what I do. I use the quantity 1.72665 times 10 to the 56th, and quantity divided by 63,161,877,033,83161,877,033, and that, and quantity divided by the quantity 2.946 times 10 to the 9th, and quantity times, here's the change, 0.7071, and quantity squared, and quantity. And then you convert back finally times the quantity 0.6216877033, and you will get 3.979 times 10 to the 26th kilogram. Now take this, which is the force, and divide it by the mass. The ratio is 4.583. I use this 0.6316 times 10 to the plus 11th, not minus 11th, as a substitute for Newton's G. And I did not score the distance between M1 and M2, except after multiplication times 1 over the square root of 2 pi, 0.7071. This means that the square of the ratio of gravity force to the mass of Urus is 4.583, near the actual 14.8 to 19.8 astronomical distance units. 1 unit of astronomical distance, or AU, is the distance from the center of the Earth to the sun. These are approximate distances, and as all the multiples that you'll hear or get from the internet all are. It fits better that Urus being 11 times Earth volume, because I can show later that Earth density, i.e. the gas atomic material, does not matter in the computational methods of both atomic distances of small masses as well as on large planets. Now we will do Jupiter. M1 of the sun times M2 equals 1.887 times 10 to the 30th kilogram, times the M2 of Jupiter, 1.898 times 10 to the 27th, is equal to 3.815 times 10 to the 57th. Then take that times the G factor, and you get M1, M2 equals 3.5815 times 10 to the 57th, and quantity divided by 63,161,877,033 equals 5.67 times 10 to the 46th. Now divide that by the radius, the quantity of the radius times 0.7071, and quantity squared times universal G like this, 5.67035 times 10 to the 46 divided by the quantity 7.202 times 10 to the 8th, and quantity times 0.7071, and quantity squared, and quantity times 616877,033. We get 1.38 1/7 times 10 to the 29th kilogram. So this is 73 times the mass of the planet Jupiter, using 1.887 times 10 to the 27th as its mass. Now, the square of this ratio of force to planet mass is 5361, and we would like to know the actual ratio of Jupiter volume to Earth's. This all becomes very important, as you'll see in a table when I've completed these narratives. So that's 1300 is 4.1 times the ratio of the square of the gravity force. It's 5361 divided by 1300. Yours has a square ratio close to its distance in AU units, but has a ratio of 4.5 gravity to mass instead of 4.1. However, Jupiter is 5.2 AU from the Sun, not 14.8 to 19.8. So it's much nearer the Sun than yours. So it's 16.7 far exceeds the 5.2 astronomical distance units for Jupiter, but it's the same orbit retention force of gravity when the volume of Uranus, 1,300 times Earth, is considered. Jupiter is 4.1 versus Uranus 4.583. Jupiter's atmosphere of Kelvin temperature is the same as Earth. Therefore, we know that Jupiter never is superconducting positrons or electrons with the Sun, even though the hard surface is much colder than the Earth underneath the atmosphere. In fact, we can say that 4.582 squared divided by the quantity 14.8 AU plus 19.8 AU, and quantity divided by 2 and quantity equals 1.20213 of the Earth's force to mass squared to distance metric. For Jupiter, the force to mass squared to distance metric using volume can be shown as 4.1 squared divided by quantity 5.2 AU equals 3.23 for an implied small deviation from the 14.8 plus 19.8 divided by 2 divided by 5.2 AU equals 3.327, comparing AU distances for the same two planets. Almost no error between them whatsoever. Now we can do Neptune. There are only going to be 3 planets in this discussion because they're the outer planets, and the 2 outer planets, Neptune and Uranus, are very, very similar, except for their atmosphere, with Neptune being mostly hydrogen. So for Neptune, we have M1 of the Sun times M2 equals 1.887 times 10 to the 30th kilograms times the M2 of Neptune, 1.023 times 10 to the 26 equals 1.93 times 10 to the 56. Then take this times the new G factor, is then you get M1, M2 equals 1.93 times 10 to the 56 divided by 63161, 877033. And that is 3.056 times 10 to the 45th. Now divided by the radius times 0.7001 squared times my universal G like this, 2.707 times 10 to the 9th times 0.7071 and quantity squared. And 3.056 times 10 to the 45th divided by the quantity 2.707 times 10 to the 9th times 0.7071 and quantity squared, and the quantity is times that big number 63161877033, and you get 5.286 times 10 to the 26 kilograms between the Sun and Neptune. So this is 5.15 times the mass of the planet Neptune, using 1.023 times 10 to the 26 as its mass, which is always up for debate, but this is the best information I was able to find. So now the square of the ratio of force to the planet mass is 26.52, and we would like to know the actual ratio of Neptune's volume to Earth, which again, various estimates exist. Turns out that Neptune has 57.7 times the volume of the planet Earth, and so this 57.7 is 2.17 times the ratio of that of the square of gravity force to mass ratio by 57.7 divided by 26.52. Neptune has a square ratio close to its distance AU of 30.06, but its ratio of 5.15 to gravity to mass instead of 4.5 to 4.1. However, Neptune is 30.06 AU from the Sun, not 14.8 to 19.8, so it's much farther from the Sun than Uranus. So 26.52 does not exceed the 30.06 astronomical distance units for Neptune, but it is the same when the volume of 57.74 times Earth is considered. Neptune's 5.1503 versus Earth's 4.583 and Neptune 4.1. In fact, we could say that 5.15 squared divided by 30.06 equals 0.882 for Neptune force to mass squared to distance. For the Neptune to force mass squared to distance ratio using volume can be shown as 15.15 squared divided by 30.06 AU equals 0.88. For implied unusual deviation versus 4.1 squared divided by 5.2 AU equals 3.23, small deviation from the 14.8 plus 19.8 divided by 5.2 AU equals 3.327 to 3.323. When we're comparing the AU distances for the other two planets. But this works out when we show the following table. The relationships I laid out here are going from Neptune the furthest to Uranus the next in line, and then there's a jump to Jupiter, which is much more close. It has a much more mixed atmosphere, but it's turning that atmosphere at 400 to 500 miles an hour at least. And so the two distances that I started with are the astronomical units of each planet, and then the years that that planet takes, because what we're going to be showing in this table is that is a very important consideration if we're talking about the exchange of a stream of energy or current between the outer planets. And you can scroll down to where the above ratios are considered at the bottom line, and which is followed by an example of how exactly you get the first one, and that would be the Neptune has an asterisk in the graphic table. So basically Neptune is 1.06 versus the next Uranus or Uranus of 1.1. The difference between 1.06 and 1.1 is just 0.04. So they're nearly identical in their gravitation attributable to the planet's mass. And of course, Jupiter, which would not superconduct, does not fall in the value of 1 at all. In fact, it's 0.03, then 1. So that's 3/100ths of the value of the other two planets. Although it may be a good guess that the sun itself is controlling the orbit of Jupiter without any necessary electric universe type of connections between them. So the 1.06, for just to be clear, this is all my own work. It's 1.06 from the 165 years divided by 30 years, and divided by g-force is 5.15 to mass ratio. 165 divided by 30 equals 5.5, then 5.15. 5.5 divided by 5.15 is 1.06. The astronomical units of Neptune is 30 at 165 years. So 165 years divided by 30 astronomical units, actually. Just type that. Well, taking 3 dimensions and 2 additional half dimensions that I have described as 8 half lines in space at right angles, I can write the square root of 8 divided by this cosine 50.8303 in quantity minus e to the power tangent 50.8303 equals minus 1.017096764. We will use this for the first time, number 1, divided by 0.3989422 to get minus 2.549484. Now, take the 8th root, it gives us 0.984131653. It also seems interesting that the error of tired light theory was 0.0143, from which you can get back to 50.830000 degrees from 50.844 degrees. like this. The quantity 1 divided by the square root of 2 pi n quantity divided by 1.00056679 equals 0.3987043818. At least I did, when I took this equation, I used it a month ago. Many changes seem to be being programmed into online calculators. They're becoming unreliable. But then I'm using a new cell phone too, so I can now show on that 0.398713291994 comes up instead of 0.3987043818. So this new phenomenon number gives, when taken to a square root, 0.631439856193. The differential between that and what I got from the same formula a month ago is 0.621439856793 divided minus 0.03400425. And that last number is the original of the quantity 1 divided by the square root of quantity 2 pi and quantity divided by 1.00566779 is 0.00286439380. And that is about 1/16th the error, i.e. 0.00284 divided by 16 plus 0.6314398569 equals 0.6161881405, or still an error of 0.000000111. So this may be the real square of 0.634304504252 from the square root of 0.3987043818. So take the inverse cosine of 0.631430422. It equals 50.844264264. And note this difference from 50.8300000 degrees is 0.01426, or the same 0.0432 number that is referred to as the residual in my calculations that are so important in the waveform that I found in my exponential formula in entire light theory. We know that 0.631618 is in fact the square root of 0.3989422. Later we shall see the square root of the quantity 1 divided by 2 pi and quantity divided by 63167 equals 1.948128, but it is bit shifted as a copy of this 8th root. It harkens back to general relativity in some kind of a mystical way. Another matching 8th root can be found by using radial cosine of 50.83, which is 0.8448, like this. Cosine of quantity 50.83 and quantity minus 0.6316187703 equals 0.2132288047. And its 8th root is 0.993914926, or like this radial cosine of quantity 50.83 minus 0.6161877033 and quantity equals 0.9977495. Of course, this assumes your calculator will return any value using radial inverse cosines. The value of 0.9998 becomes critical in the energetic valence. I chose this value to compensate for the barycenters as the three-body gravitational model or orbits that dates back in history would indicate originally. Then the 9 hyperbolic cosines, I would begin by assigning the property that the quantity 63161877033 times 3 to the power n quantity to the power e n quantity times the cosine of the quantity 5 and quantity divided by 2 pi and quantity divided by the square root of 3 cosine 5 and quantity. And that is equal to 0.414660539. Now pair this with the cosine of the quantity square root of 2 divided by 0.414660539 and quantity divided by pi and quantity, and that is 0.998205032. I explain this as a neutron constant. All following from here on, all the following cosine functions that I give you have to be done in radial mode. So set your calculator off of decimal mode by pressing the radial button if it's showing, which then change the degree. It'll mean that you're in radial mode, and if you want to change the degree mode, you have to press that button that says degree. It's a space-saving device. But the energetic model needs to have a kind of restatement of the relationships between the exchanges of forces with the proton electron cloud if it has to serve as a central force. There may thus be an internal forces opposing the different centers from which are different from the center of mass. This occurs in the three-body model. Reference on this would be the barycentric, page 155, An Introduction to Astrodynamics, circa 1960, Academic Press Incorporated, London. There's no ISBN, no International Standard Book number. I use 0.999820 times the quantity 0.63161877033 times 3 n quantity up to the exponent of e n quantity times cosine of phi divided by 2 pi divided by the square root of 3 times the quantity of cosine of 5, and that is equal to 0.4145861. The value is slightly different from 0.4146605. So what I want to take the average of these two, it is 0.4145861.047. So that 0.4145861 divided by 0.4166053.049 equals 0.8292466.396. Actually plus, but which simply yields 0.4146233.198 as an average. So the cosine quantity square root of 2 divided by 0.4146233.1 divided by pi n quantity is equal to 0.46629028189. And then for paired cosines 1 and 2, we begin again with the prior value of 0.4662990. So that times the cosine of the quantity square root of 2 divided by 0.4146233919189 and quantity divided by pi and quantity is 0.2174266.290. I'm going to give that a label of CS1, the constant CS1. So what we took the cosine square root of 2 divided by 414 divided by pi, got 0.46629. Then we stuck that 0.44629 into the cosine of the quantity square root of 2 divided by 4146233399189 divided by pi. Came up with this number, CS1, 0.217426629. Okay. Now we're going to do the second constant, CS2, because we have to have something, as the cosine of the quantity square root of 2 divided by 414623339 and quantity divided by pi and quantity times the cosine of the square root of 2 divided by 0.414623339 and quantity divided by pi times cosine quantity square root of 2 divided by 0.414623319 and quantity divided by pi. And that equals our CS2 of 101.3838874. So now we're going to combine those. Combine CS1 and CS2 as 0.101383 plus 0.2174266 to get 0.466291131. So then, as expected, the result of this 0.466290 up to 0.60223269 is equal to this cosine of 50.83 degrees, which is approximately equal to the square root of the quantity 1 divided by 2 pi, and that is 0.63167. And this is approximately close to 0.63161.877.033, but better approximates the codependence between, because 0.631602386 equals the square root of the quantity 1 divided by the quantity 2 pi and quantity and quantity, or the results can vary on this. 0.63161.877 equals the square root of the quantity 1 divided by 6.283 equals 0.3989. And so the square root of 0.3989481634 equals 0.6316234. Okay. Now, if I can find my place. Anyway, I broke it up so everyone can verify this important relation to all of my prior work, and especially in this work. One really big issue is my Android cell phone calculator updates. Even strangers, it's giving me cosine of 50.83 has the same value as above, as 0.631623456 instead of 0.888448468174 in radian mode. If rad is not showing on the display again, hang it up. The problem is maybe in the software. If the calculator shows degree on the keypad again, switch your degree to a radian mode. The radian of cosine 50.83 should come up as 0.88844846. Because the normal distribution is an infinity, the area under the normal curve is really being approximated by the convenient function of 1 divided by 2 pi, which is assigned as the ordinate of the normal frequency distribution. But it is much more approximate than my research on calculations without such variables involving infinities. It cannot always use the indefinite integral standard. I can't, as I cannot tolerate error to define the force that uses rotating spaces as orbits in tandem with dual paired paths. This is much like picture, in which my model appeared in varying coupled transcendental gravity radiation that I copyrighted in the last lost physics model video seems to be. So 0.16629011131 up to the quantity exponentially as 0.60222939 equals 0.6316187, which is approximately equal to the cosine of 50.83 degrees, or the opaque angle of the Great Pyramid at the center of mass of the Earth. Is also my universal G of gravity constant. The quantity 0.04329 divided by 1.06849, and quantity divided by 2 times 9.463 times pi equals 0.602234. And I'm going to give that the number CS3, constant 3. Confirming that 0.16629011131 to the exponent 0.256113748 is equal to 0.63187733. I have found recently reconcile the difference between the normal distribution function, which requires a variable x, and the standard deviation from -3 to +3 standard deviations, that the function 1 divided by the square root of 2 pi becomes the conversion of circular or orbital space into variation about a center point on a number line, like this 1 divided by the square root of 2 pi equals 0.398942228. I intuitively have always felt that the universal G should be derived from this conversion invariant. The quantity square root of 0.398942271 and quantity plus 0.63161877033 divided by 2 equals 0.63161877031. And I should note that 0.398942271 minus the quantity 1 divided by the square root of 2 pi and quantity times 0.631618777 is equal to minus 1.00416. Note also, as a forward reference, that 0.0028 divided by 0.004151 is 0.6745, which is exactly one average error in standard deviation theory of the X normal distribution being a standard deviation. The small difference comes up as a second indicator of another dimension. It indicates we are doing a virtual measurement of some perfect random independent variable. I will use the 0.432 that was found in angular quantitative analysis and tire light theory as an exponent in a moment to yield 1.0028. It is obvious that 0.6316187 times 0.6316187 equals 0.3989421821. So the 6 to the 8th digit, if not a 227 but a 218, makes a 0.000001 difference over 1 billion by not using the second 7 in the 8th decimal place of universal G. As I've said, it is not obvious to use the universal G constant as it needs conversion into the valence space to gain an advantage over tensor-based quantum and relativity theories and combine quantitativity as the post-1948 color television lust-driven Western atomic model education system and particle experiments called it. Now in computing CS1, we use the formula for which the cosine of the quantity square root of 2.414623331 pi equals 0.46629028189. We also saw similarly that the quantity 0.466292 plus 0.60223269 divided by 1.068522831 is equal to 1.0000. Well, actually, I don't know how many zeros. I can't reach that on my calculator. That says that I to an unknown unknown decimal place is associated with 0.60223269 from CS3 and introduces a new division by an offset from 1 of 0.068522. I could use this division constant mod 1 times 10 equals 0.68522, or because 0.04329 divided by 1.04689 divided by 2 times quantity 9.9824714 times 3.14159 and quantity is equal to 0.631618. But exactly again, I see that also this exact factor of 1.06852 up to the 0.432 is equal to 1.0028, which again about the difference of mass of the neutron and the proton of 0.002306 times 10 to the minus 27th kilogram. The electron cloud would add about 10 to the minus 31 kilograms per electron. There are about 5 or 6 half dimensions here. The fifth being exponential or volumetric expansion and contraction, and a pair of rotational vectors left and right known as left-right symmetry. A major barrier with this kind of math is that we can never know absolute right from absolute left except relative to some point, and there are no stationary points because of the volumetric and rotational pairings. This problem has been the root cause and misconception about what goes on in the atom from the time that science in the USA departed from the European principles of the atom. Oppenheimer and Feynman share a common personality trait that I can note. I'd say certainly prompted Oppenheimer to recommend Feynman to the College of Berkeley to be a physics professor. They were both big boozers. In 1948, the result of the fiasco can be best described by this background information. Here's a hypertext link, https://en.m.wikipedia.org.wiki. It's the history of quantum field theory and link. It has become a law of physics since the period of darkness that there is no parity, no up, down, anything, just like there's no way of marking something that moves and with a magic marker in order to observe left from right. But the reader needs to know that most often the adapted way of implementing a solution is not the best way. Einstein dwelled on this type of equivalency principle for quite a bit of his career. Briefly, the quantum theories that led us into the error called the Standard Model, which is really the inclusion of Einstein's relativity into some atomic chromodynamics failed. The quantum chromodynamics was a near-perfect description of how a not yet invented but much wanted color television screen pixel system works. It has, however, after years of chasing a rabbit track around the particle path observations, failed to give us any predictive or dimensional data system for the so-called forces that are as well made up of mental labels for mental revelations or failed combination of that errors would be quants. The history of mass of sun times mass of planet being expected to relate like light propagation to the distance of the force of gravity being there traveling squared was perhaps the first true mental revelation, since the idea of an all-powerful God or godlike beings controlling planets, or those planets themselves being gods. They had no calculations or quantitative analysis at all, and the normal bivariate distribution would not be published until 1955. I asked the listener and reader to try to imagine what it would be like to calculate angles of a round spring-sided pool table and billiard ball sports without radial functions on a modern calculator. Yet this is what they attempted, as did Einstein with its failed tensor panacea that Imagineers, to coin a Disney term, the math variable as a force independent of time. As Feynman claimed, his mesons, photons, and many other particle paths that he drew on paper to look like stringy, bouncy billiard balls were capable of doing. He claimed photons made intelligent decisions to effect anywhere in time or space according to their own will, instead of all-powerful gods. While he swore he was an atheist, his domestic youth was influenced by the social democracy of combined religion and science. Both parents were Jewish, and he spent some of his defining odd belief systems saying it was not possible to ever understand it. And that was the nature of physics. It turns out that 0.46629 plus 32 equals 1.068522. Compared with 0.46629 plus 0.6022 equals 1.06849. With the addition and CS3, quantity 0.04329 divided by 1.06849 and quantity divided by 2 times 9.463 pi equals 0.602234. Confirming that 0.1662901131032 to the exponent 0.25611134748 is equal to 0.316187733. To state higher light theory in this valence more perfectly, it's the same way that I could say that the quantity 0.04329 divided by 1.06849 and quantity divided by 2 times the quantity 9.9247146 times pi and quantity equals 6316187. Or I could say the quantity 0.04329 divided by 0.06489 and quantity divided by 2 pi times 6278768588350 equals 0.6316187 times 10 to the 11th power. Notice that just for fun, 0.0685.0432 times 2 equals 3.148. By grouping this equation differently, we can see that grouping behavior effect that can be found in using different styles of groupings and equations. The quantity 0.04329 divided by 1.06849 and quantity divided by 2 times the quantity 9.9247146 times pi and quantity equals 0.6316187, because the quantity 0.04329 divided by 0.6849 and quantity divided by pi times 9.996676 equals 0.99247, not 9.9247. So one one more little shifted point as 1.06849 and 0.6849 have this shifted symmetry. I would like to know it. So some way in the middle of the right, left, or up, down parity debate, perhaps this can be addressed. Another odd example of 0.000432 is that 5.000432 times 2 factorial constants is approximately equal to 6.022334, which is CS3. If I multiply 2 factorial factors by each other, I first obtain factor 1 by log of the quantity 5 factorial divided by 90 times 5.055427864. I do this first exactly like this. 5 factorial divided by 90 times 2 times 2.527713932. And that should give 0.63131877033. If not, they can check your calculator, and it may not work well. But again, I could use the log of the quantity 8 factorial divided by 90 in quantity times 0.238231815 to get universal G again exactly. Also, 5.055427864 times the quantity 0.238231815 times 5.000432 equals 6.022334, which is CS3, but it's bit shifted one decimal place over. For your reference, that CS3 is 0.602234. From these factorials, we begin a whole new journey into the world of general relativity and how the basic ideas can be used to fit into a better, more modern understandings of higher and lower dimensions, of how these dimensions relate to energy density of any particle or mass of particles. The big problem with the Earth orbiting the Sun in Einstein's time was that Newton said gravity was a force, and that it is like the Earth being like a water ski or rafter behind a boat. It can only have pull unless the force can also push. Einstein knew that the entire solar system was in motion. It seemed quick and dirty as a solution to say that the atoms being towed behind the bent space were the result of their immediate location exclusively. That way, the disk shape is always maintained and does not lag behind the sun as it moves in any kind of arc. Then such distinctions as a line or an arc become what he said was relative to the observer. But no, I disagree. We can know that mass of particles behave the same way as any individual particle behaves. However, its energy density is what becomes relative to the way it moves at very, very, very high speed near light. A line is usually the first dimension on an unfortunate paradigm. This is a low number of 1 versus the higher dimensions or degrees of freedom, which in a way is to say how many ways something is moving at the same time. But this gets into bulging in and out as it would be viewed, and not waves strictly speaking, in terms of 4th-dimensional movements. This whole discussion for why it became accepted probably has something to do with Jupiter. The history of this topic dates back to before Newton, who knew that light spread out in an inverse square window pane law fashion. So although he did not publish that formula, his students did publish it as his work after his death. Today, according to my research, there is more than one mode of gravitation going into the sun's solar system disk. Neither of the two modes is a match to the early version of the light speed or space warping control mechanisms. To rehash old videos, I would add that the Earth is still to this day attributed an average mass that in reality is only about 0.234 to 0.238 times as great as the published mass. Jupiter's solid surface is 12 Earth masses. It has a very circular orbit. The surface black body temperature is 124.4 degrees Kelvin, which I will compare to Earth's black body temperature,
which shows at sea level it comes out to be 287 degrees Kelvin. We will just assume Earth is a 287 degree Kelvin planet. To try to be precise, Jupiter's atmosphere is moving 400 miles an hour relative to the free space at a temperature of 4,900 degrees above 0 Kelvin. It is very warm compared to the actual surface of Jupiter. Jupiter is very large. Saturn, Uranus, Neptune are reported to be about the same, 9 to 12 times Earth's, either as diameter or volumes, depending on the authors. Saturn, for example, is a planet itself being 12 times the mass of the Earth, and the atmosphere another 2 times, or about 14 times the Earth's size, to capture a great deal of solar energy. There are several ways I found to assume Jupiter is 12 Earth's sizes, plus its hot temperature energy for another 2.2. To be of scientific interest, an equation that exponentiates the value of a number e, which is 2.7182, has to have a value of 1 plus about 15 zeros after it. This is because equations are a sure indication of a wave equation or function, if that's the case. The one indicates one complete cycle. The other developments in this most helpful theory, if gravity is as a force in the form of waves is ever to be achieved, is, as the above discussion of the radial residual of how it was developed algebraically into illuminates for us, for the gravity we recently transferred by a wave would work best as a sawtooth wave. The Crab Nebula, and when it had an atomic collision of massive black holes, was said to have emanated gravity waves, but there was no capture of the waveform. Now, to digress a bit, the sawtooth waveform is the only wave that can contain any distance information and return it to the sender in some fashion, even if delayed. The science of waves states a law of physics that says that any waveform can be constructed by using sines and cosine functions exclusively. So in this energy and energy density multiple discussion in math, those exponent components and all their related information is extremely important. And even more important are the properties of that related information as it relates to either linear, one-dimensional, or curved, two-dimensional, or spiral, three-dimensional, or energy density fluctuations and vibrations, four-dimensionals, and other above plus radial linear geometries in combinations. For example, I could say that if we take a look for the difference between the quantity 1 divided by the square root of the quantity 2 pi squared times 2, we get mathematically 0.6366197723, which is different from my universal g constant. But 0.6366197723 minus 0.631618777033 is equal to 0.0050010020003. For at any given time, if 0.6366197723 minus 0.63197723 occurs, that would indicate a difference of 0.005 very precisely. And that brings us to the subject of a hypothesis that if energy transfer is happening between atoms by way of an undiscovered wave form, then there is a variation in that transmission by which universal g may be an average value and not an absolute constant number, or may jump between values just like the jump of orbit distances of an electron from the nucleus of an atom does, which in turn does come up early and often in experiments like double slit experiments to reveal both wave and particle properties that are not consistent with time-based line intervals. To be brief, I have shown indications of my works that are in need of methods and incorporate multiple systems of computation of location and orientation that are consistent with themselves, such as Poincare's sphere curvature space and my paired inverse coupled transcendental gravity radiation, my Wintelstein gravity equations, my tired light waves, and the radial and factorial function shown in this video. But most of all, it comes down to the universal g constant and its importance in physics, which I have shown is an essential to find the meaning of the 1960s formulation of total mass divided by kilometers. This relationship would change when using miles or pounds, because there really is no known connection between the magnitude of those particles that are attracted by forces, both magnetic and gravity related effects, distance, and then the distance. It actually relates to those two processes, have never been quantified or discovered until the release of this copyrighted paper and its interpretation that I've done solely on my own work. There are no other video or publications